Great, thanks Tarek. Hello, I'm Karen. I'm a product designer here at Snap, and I help design Snap OS as well as several of the core experiences. And this morning, you heard the story of our technical evolution, and now I'm going to share how our design thinking has evolved as well, and what you need to learn to design amazing lenses for spectacles. And in this session, we'll walk through new choices that you'll have when designing for wearable AR. There's a lot to cover, so we'll start really broad with the product space, then get a little bit more specific to spectacles, and then get even more detailed with UI elements. And today, we'll cover spatial design, new product opportunities, and new fundamentals to this medium. Then we'll take a look at concepts that are more unique to spectacles. And then we'll look at interaction concepts or interaction mechanics for your lens, such as selecting an input paradigm, considering user posture and movement, how to position and size your content, and then finally UI details for your lens, such as working with form, color, motion, and spatial audio. And when you're first getting started, we really encourage you to embrace the all-new possibilities that spectacles brings. Lenses on spectacles can be spatial and unbounded, 3D, larger than life, and bigger than a phone screen. Our lenses can enhance the world. We can map spaces, track real-world objects using SnapML, and augment our surroundings. We can free our users to move. Without cords, we're untethered, we're capable of movement and bright enough to be used outdoors. Our lenses can use natural interactions to create intuitive and expressive multimodal inputs that combine hand, voice, and body. And finally, we can be hands-free. We're no longer stuck holding a phone. Our hands can interact with lenses or remain engaged in real-world tasks. And each one of these exciting capabilities offers all new ways to design. Our wearable system enables us to consider the many human senses. We can now design for sight, sound, and touch to create more immersive, more interactive AR experiences. And with spectacles, we can see with our AR display, hear with our integrated speakers, and directly touch with hand interactions. By thoughtfully combining visuals and audio cues, we can further the perception of touch. And because our spectacles are worn by our users, we also have to consider our users' physical proportions. And of course, we all come in different physical dimensions. We have different arm lengths, different hand sizes, and different head heights. And these variations all come into play when positioning content. Hand interactions are also incredibly unique and personal. We all have different sized hands, different limbs, and even make the same pose in slightly different ways. And so ultimately, we need to consider adjustable and adaptable interfaces to fit a variety of users. And AR placed in the world brings all new challenges that we also have to deal with reality and physical space. When content exists in sixth-off space, we may be able to move and see it from all sides. There might be real-world obstacles and collisions that we now need to adjust our content around. We're no longer limited to a really controlled user perspective, like screen space or like a phone with fixed edges. And there's no longer one single best place to put your content. It really can vary based on the needs of your experience and your goals. And where to position content becomes a new major design choice. Now, let's get a little bit more specific to spectacles. This morning, you heard Daniel describe our waveguide display system. And understanding this display system is really essential to design comfortable experiences on spectacles. Our display projects content in a vertical portrait aspect ratio with roughly 3 to 4 proportions. And the term field of view describes the possible area for AR display, or in other words, the size of AR that the spectacles wearer can see at one time. And our focus plane is set about 1 meter away from the user, which means that looking at highly detailed content will be the most comfortable about 1 meter away from the user. And the spectacles display creates an image for each eye that your brain actually combines into a single overlapping image. And the size of this overlapping image changes based on the distance away from the user. The visible display area is smaller when it's closer to the user, and it's much larger when it's further away from the user. And our displays have complete overlap at 110 centimeters away from the user. At this distance, you'll be able to see content that is roughly 53 by 77 centimeters that uses the fullest possible width of the display at that overlap. And Snap OS has been designed with flexibility in mind. As a lens creator, you'll have a lot of options about how your lens works, looks, and feels. To avoid getting overwhelmed, we really recommend that you let your use case guide your way through these different design choices. In yesterday's keynote from Evan, you might have heard the idea that Snap OS is designed around the idea that hands are home. And what does this mean for you as a lens designer? While running your lens, the OS persistently renders one small button on the user's hand. And this gives the user consistent access to system controls. We've reserved the rest of the space on the hand for your lens, for actions, for menus, for immersive effects related to your lens. Inside your lens, you're in control. And we really like using the space on the hand for immersive visual effects and quick look, simple actions that don't require continuous visibility. The Cricket's lens takes you inside of a bug's life by applying cricket wings directly to the hands to teach you how to chirp. And Beatboxer applies boxing gloves to the user's hands as a core part of their mechanic. And while your lens is running, that same system button will open the standard system menu, enabling users to view lens information, open system settings, and exit back out to Lens Explorer, so that you don't have to manage these behaviors as a developer. Now, let's talk a bit more about interaction mechanics. When designing your experience for spectacles, you get to choose which type of input you'd like to use. Our primary system input is hand interactions. And users will perform the typical system gestures of point and pinch to get to your lens. Once inside of your lens, you can choose to use hands, voice, or the custom mobile controller as your primary input. And you also might consider device position and real-time object trackers as additional inputs. And as you can see, selecting different inputs can create really distinct types of experiences. The LEGO Bricktacular lens uses hand interactions for enhanced dexterity to create intuitive, creative construction. Imagine Together uses voice interactions to radically simplify the number of interactions that are needed in order to create magical 3D models. And Tiny Motors uses the custom mobile controller for a familiar gamepad with world-scale action. And it's also important to keep in mind that each of these different input paradigms will have different design considerations. And here at Snap, we've built standard code components to help handle input logic. The Spectacles Interaction Kit, SIK, offers a variety of modules for each of those types of input, as well as seamless support for both direct interactions and indirect interactions. As a designer, you can choose which paradigm is right for your experience and your goals. For direct interactions, we really like using those for tangible, up-close, immediate interactions that can feel more like real-world behaviors. Indirect interactions are really great to put a little bit more distance in between your user and the outcome action, and they can feel familiar, like pointing with a VR controller or pointing with a desktop mouse. And no additional developer effort is required to support either mode. If you're using SIK, the targeting system will automatically switch based on the distance of the intended target. And for either mode, it's really important to show some type of targeting feedback on all interactive elements. And you can choose how to style this feedback. ROS uses a typical yellow outline or yellow glow to indicate when a user is actively targeting an element. And because spectacles are untethered, lightweight, and see-through, we really expect people to use spectacles in a range of physical motions and postures as they move around their everyday lives. When designing your own experience, consider which posture might be the most helpful for your use case, whether that be standing, seated, lounging, or on the go, in active motion or movement. And this is important because each posture might prefer slightly different sizes or slightly different orientations of content, or slightly different positions. And different postures might also encounter different real-world obstacles that need special consideration, like tables or soft furniture or walls. Different postures may also prefer different types of anchor dynamics. And we use that phrase, anchor dynamics, to describe the logic of how content is positioned in a scene. Content that is fixed in the real world can exist as a real-world object, or content can follow the user's head or hand as relative anchors. And in those scenarios, the content will move as the user moves through the scene. Choosing an anchor dynamic will also influence what size your content can be, as well as how portable your experience it is, and how easy it is to use while in motion. So as an example, in the chest lens, content that is fixed in the world is simple, flexible, and native to AR. Users can move around these experiences as if they're real-world objects. Content that is fixed in the world can also appear larger than life and play with scale. But there is a bit of a trade-off that fixed content can be left behind in the real world or appear lost if your user moves away from the initial launching position. And so it's important here to really choose what suits your use case. If you don't have more specific movement needs, choose fixed anchoring to start, as it is the most flexible for other types of design choices. And we found that experiences that are designed to be used on the go, continuously in motion, are easiest to interact with UI that follows the user and comes with the user. And this ensures that content is never left behind and that it's always easy to access. We especially like this pattern for critical privacy controls like mic or like camera access, seen here in my AI, so that your users can move around in the experience, explore the world without losing these critical interfaces. And content that is meant to be used on the go is also typically best when it's smaller and a bit glanceable, so that we avoid blocking the user's full field of view if they're in motion. We want to keep our users engaged in the real world. And SIK offers several different following behaviors to choose from that vary in the amount of buffer or kind of how responsive they are when they follow the user. And for experiences that require a lot of movement or activity in a scene, content can also be anchored relative to a user's hand. Some experiences, like Loop Lab, really like to keep controls nearby, but not visible in the field of view. And so hand menus like this pattern are a great way to keep content accessible and easily accessible without introducing any distractions to the field of view. And it's really important to position these types of hand menus near the user's non-dominant hand so that the dominant hand can still be used for targeting and selection. And in SnapOS, we use containers as a standard affordance to move and adjust spatial content. Containers use manipulation around a spherical coordinate frame so that users can adjust content in different postures, whether standing, seated, or lying down, whatever is the most comfortable for their current posture and arm length. And when helpful for the use case, some containers also offer the option to change their anchor dynamic from following to fixed. And so as a developer, you can use this pattern to give your users more flexibility to move content around real-world obstacles or to adjust content for their own personal comfort, or if your experience has multiple panels that need management and movement. If you have a near-field interface with direct interactions, we especially recommend using the container pattern so that users can move the interface to the distance that best fits their arm's reach. And containers are available in the SIK for easy adoption. Okay, that's a lot of information. Once we've designed the constraints for our spectacles experience, we're ready to get more specific on how to position our content. And new for spectacles, we need to think about positioning and sizing content in each axes, X, Y, and Z. And positioning here will be guided by your use case, your input paradigm, and your expected user motion. And sizing is constrained by both the display size at a given Z position and the recommended minimums for hand interactions. And altogether, these choices will shape the comfort, the usability, and the overall feel of your experience. So starting off with the Z-axis, some use cases will call for positioning content closer to the user, while other use cases may prefer to be further away at that full-width convergence plane. As an example, smaller UI might prefer to be much closer, while larger, more experiential content might prefer to be further away. And if we recall that the overlapping spectacles display area, it becomes smaller the closer that it is to the user in the Z position, we end up with these two distinct options. Near-field positioning that enables direct interactions within typical's arm reach range. It has a smaller display area, and it's best for brief navigation and glanceable nearby controls. This really puts your user directly in the action and directly nearby. Then, far-field positioning uses indirect interactions. It can take advantage of that larger display area, and it's best for more detailed content experiences that might be used for longer periods of time. And we recommend using these typical Z positions for near and far field content. At these distances, these are the corresponding sizes in the X and Y plane. 35 centimeters is very near field. It's about the distance of where you might hold up your hand. And we like that distance for hand-anchored quick controls. And here the display size is 13 by 24 centimeters. A bit further out, at 55 centimeters, This is near field. The arms reach for slightly larger menus and other controls. And here, our display grows to 23 by 38 centimeters. Then further, at 110, far field, which is the best default if you don't have other more specific needs. This is closest to the focus plane and where content will appear like the sharpest. The XY display size is 53 by 77 centimeters. And then finally, we have an ultra big option. 160 centimeters away from the user is big if you need it, but not so far away from the focus plane that the images aren't clear. And here, the XY display size is 75 by 112 centimeters. And now, for the most comfortable experience, it's important to always size your content to fit within the binocular overlap width within any of those XY planes. We want to avoid putting content in the monocular edges of the field of view where only one eye can see the content. And this usable width will vary based on the distance away from the user. In any given XY plane, it's also helpful to try to center content in the user's field of view. This is the most neutral head position in which to view the experience. It requires the least head motion and will also ensure that users just automatically see your content. This also helps to avoid any potential color distortion or display artifacts that might be near the edges of the display. And content that is lower in the field of view will be lower effort and also more comfortable to target with hand interactions. And we recommend keeping the content sized to fit within the field of view at any given XY plane. This tends to feel more deliberate and easier to use and ends up making the display edges feel less noticeable. Content that doesn't fit in the field of view will feel larger than life, slightly disorienting, and slightly overwhelming. And we really recommend to use that only if you're intending to have a dramatic scale effect. Users that are new to AR also might not realize that they can move their head around and to look around a scene. If you place content far outside of the field of view, there's no guarantee that users will find it unless you really specifically guide them there. And for vertical positioning, it's really important to consider the spectacle's bore sight angle rather than the horizon in Lens Studio. Unique to spectacles, the display bore sight is tilted slightly down to support a more neutral head resting position, or resting head position. And consequently, the center line of the display image is slightly rotated below the horizon. And so what this means when you're positioning content is that you might end up a bit lower in the global coordinate space compared to when you're creating for mobile or for desktop. And if you're using hand interactions, it's also important to consider the size of interactive elements to support comfortable and usable interactions. Small buttons are more difficult to target and use with hand interactions. We've created some sizing guidelines to help here. At any distance, targetable elements should be at least 2 degrees in angular size. And we can convert this to real-world centimeters at different z distances. We've outlined 3 typical standard sizes that we like to use. Small, which is the minimum to support usable interactions, medium, the best recommended default, and a larger upper bound, beyond which size no longer helps with targeting. At 55 centimeters, we recommend 3 centimeters as a default best target sizing. And at 110, we recommend 6 centimeters. And here, the recommended size refers to the interactive collider on an element. Visual meshes can be a bit smaller, provided that the collider meets the minimum standards for these comfortable interactions. For more details, please consult our online docs. Okay, now we're getting a little bit more detailed into the UI details. In Snap OS, our interfaces are typically a mix of 2D shapes and 3D forms, where form exists in 3 dimensions with height, width, and depth. Using 3D forms helps encourage hand interactions. These round geometries are much more inviting to reach out and touch than flat planes with sharp edges. These 3D planes also provide some inherent back, some mass when viewed from different sides in 6-DoF space. And these new forms can also create more compelling interaction feedback opportunities with new motion and depth opportunities. Buttons, interactive elements, and hero objects all tend to work best as 3D forms. For legibility, we like to use 2D shapes for text and icons. This avoids distracting edges when content is viewed from the side or from different angles. And 2D planes and meshes can also function as backgrounds and tiles to gather multiple elements. Our hardware display system also affects what color looks like on spectacles. The display system adds light to your view, combining red, green, and blue light to create full color AR on top of your real-world view. This additive color space renders color differently than desktop or mobile color spaces. And unlike VR or mobile platforms, designers for spectacles need to think in this inverted color space, where white becomes the boldest, brightest color in the scene, and where the additive display can't render black tones. Black tones will appear transparent. And alpha is proportionate to luminosity, so 50% alpha will appear half as bright, or like a mid-tone gray. For designers, it can be helpful to consider patterns from dark mode, from desktop or mobile for inspiration. Also, because of this additive color space, for visual comfort, it's important to avoid white backgrounds with dark text, and instead use dark backgrounds with light text. This is important for visual comfort and clarity while we're reading. And uniform color regions may also highlight display variations, and so using textures or subtle gradients can help you make it so that your users don't notice that. In our interfaces, we tend to use unlit materials with baked-in lighting and simple shaders to mimic PBR effects, to avoid the computational overhead of environmental maps and more elaborate lighting schemes. Because of our small physical size, the spectacle's hardware does have some performance constraints. And so as a solution in Snap OS, our buttons have highlights that are directly baked into their textures. In your lens, it's important to consider the right trade-offs for your experience to balance power consumption, runtime, and desired visual appearance. We also use motion in our interfaces to guide the user's attention from one point to another. In 3D space, this is especially helpful for wayfinding and for orienting users. Motion can cue an origin point and also help ease transitions between different elements. And here in our Palm UI, we change both scale as well as position across origin and destination. Settings scales upwards and outwards from the status watch to draw your eye into the real world. Lens Explorer does similarly from the Palm UI. And these effects are really important to keep your user oriented and aware. This can be especially helpful when opening content from the hand or opening larger content from smaller menus. We also use motion as interaction feedback, or motion as interaction hints for feed forward and feedback. And these moments of motion can be opportunity or moments to express delight, an opportunity to express a stylistic language. In Snap OS, our Palm UI buttons jiggle and flex to hint at an incoming poke action. Our pinch buttons hint at their expected pinch action with a progressive squish animation that as you close your hand around the button compresses itself in that intended hand shape. On hover, our tiles in Lens Explorer and video calling move forward in Z-depth to show that they've been targeted and that they're actively in focus. Tiles may also push backwards to show when they've been selected as a resulting outcome from your action. And each of these moments brings a sense of playfulness and physicality. It's a real opportunity to bring more of the physical world into our digital spaces. And for our other senses, spatial audio represents an all-new creative opportunity for AR experiences. Sound sources can be positioned in your real-world scene with realistic distance and directional behavior. As your user moves through their scene, they can begin to hear what they're seeing in real time. And spatial audio can add a sense of realism and immersion to your digital scene, making the experience more plausible, as if it were a part of real life. You can also use spatial audio as a directional cue to grab the user's attention, to signal where content might appear from, or from outside of the field of view. And so, to recap today, we've covered a lot of new ideas. Here are some best practices to avoid common issues that we see in lenses. Remembering to design for user movement. We need to expect different postures and movements during our experiences. It's important to provide adjustable controls where possible and ensure that users can follow, summon, or recall any critical UI. Then, we really recommend to keep content in the field of view, and if not, guide our users to out-of-view elements. Provide hints to look around to find hand menus, elements on the floor, or elements outside of the field of view. Next, explain any diverging interactions. We recommend using system patterns as much as possible to reduce learning curves for your users. And if you diverge, clearly explain any interactions that differ from these typical patterns. Next, show targeting feedback on all interactive elements. Because these natural interactions with hand and voice are so new, there can be some uncertainty. And so let your users know clearly when an object is in focus, as well as following target sizing guidelines, sizing buttons and interactive elements to be easy to target and pinch. And finally, following the basic visual comfort guidelines to stay within the binocular overlap widths and to work with the additive color constraints. Now, when it comes time to build your experience, we have many helpful resources available online that anyone can access. We have Lens Studio docs, we have templates and tutorials, we have an entire section that recaps this talk, how to design for spectacles, as well as additional in-depth technical guides. Also online, we're also pleased to share that the Spectacles Interaction Kit, which as we've mentioned is a collection of code components, modules, and assets for Lens Studio. SIK dramatically streamlines the process of developing for spectacles, providing the common building blocks that can be easily used to build these interactive experiences. And later today, Eric will describe SIK in more detail. Fantastic. And now that we've covered the core concepts for Wearable AR, we hope that you feel empowered and inspired to create something new. After the lunch break, Yuhao will share the next practical steps of how to build a lens for spectacles. Thanks for listening.